In this lecture, I'm basically going to just cover a few definitions of asteroids, comets, and meteors. If we are interested in finding out whether there is some potential in the future for life on Earth to be destroyed by one of these things, we need to know what we're talking about first. And we need to distinguish between the threat of the different kinds of objects that might cause damage and which ones are more likely to cause a devastating impact than the others. And these three things are objects that people often get confused. So it's important to really know exactly what we're talking about to really understand these definitions. So I'm going to start with asteroids. Now, asteroids, as you can probably see in these pictures, are basically chunks of rock. So, they are completely irregular. They're not round like a planet. So this is why they wouldn't be considered a planet. They orbit the sun. So that's similar to planets. They do orbit the sun. Most of them are between Mars and Jupiter. There are others that are not between Mars and Jupiter, but the vast majority of them are. There's millions of these things. Most of them are tiny. The ones you see in this picture, you can sort of see some lines here, here, here. Those represent 10 kilometers, and on this last picture, that's a scale of 5 kilometers and even a close-up of 2 meters on this one. So these things are relatively small, not too big. There are a few that are hundreds or even 1,000 kilometers in size. Not very many of those. So you may remember the dwarf planet Ceres, which is an asteroid, and it's a dwarf planet because it manages to be round. But that's about as big as they get. And the majority are little grains of dust. So this is a diagram from your book that sort of shows the location of these things. So the sun's down here in the middle. This is the orbit of Mars, and this orange circle is the orbit of Jupiter. So you can see each of the white dots in here represents an individual asteroid, and these are pretty big ones. And you can see the huge majority of them, as I said, are between Mars and Jupiter. This is called the main asteroid belt. However, you can also see, if you look more closely, that there are ones that get inside. And these, of course, are the ones that we have to worry about. We sort of have to worry a little bit about the ones in the main belt too, because if two asteroids collide with each other, then that changes their orbit, and maybe they could hit hard enough to send one flying from out here towards it here. And so that's the kind of thing we have to worry about. And that's a very unpredictable thing because there's a lot of asteroids out there. We can't possibly find every little rock that's smaller than 10 kilometers across that's between Mars and Jupiter. There's just too many, and we can't predict what's going to happen with all of them. So that's one of the concerns. On the other hand, it looks in this picture like the asteroids are all really, really, really close together. And if you've seen movies like Star Wars that have asteroids in them, and they go through an asteroid belt, it looks like the asteroids are really close together, but that's actually a misconception. If you think about this amount of space, this is at about 1.5 AU, and this is at 5 AU. This is a huge amount of distance. I mean, that's the same amount of distance as it is from Mars to the sun. That is a huge amount of distance. And so even if you have millions of asteroids, there's going to be a vast amount of space between them. If you were flying a spacecraft through the asteroid belt, you would not have much trouble dodging asteroids. You might hit some of the little dust grain-sized ones, but you're not going to hit any big ones. You're not going to be playing a dodge game like Han Solo does in Star Wars. Not so important for us, but just since it's in the picture, you can maybe see there's also a few asteroids out here near Jupiter. They're actually orbiting pretty much at the same distance as Jupiter, and those are called the Trojan asteroids, which has to do with a particular location that they are from Jupiter. Next thing we want to talk about is comets. The picture here is Comet Hyakutake, which passed by us in the 90s. And comets are a bit different from asteroids because in addition to rock, they have a huge component of ice, like just water ice. They are frozen ice with some rock mixed in. A common description that's given of comets is that they are dirty snowballs. So if you think about a snowball that has a bunch of dirt and rock mixed into it by some vicious little kid, that's basically a comet. The head of the comet, which is this part, could be very small, but could also be 1,000 kilometers across. We often think that Pluto, one of the reasons we recategorize Pluto as a dwarf planet is because it's made of ice and rock and it's about 1,000 kilometers across, so that's just like the head of a comet. Most of them are much, 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 much smaller than that, but we found enough out there that are bigger that we had to think about reclassifying Pluto. The tails can be thousands of kilometers long, but they only get a tail when they come into the inner solar system and pass near the sun. Most of the time, comets live out beyond where Pluto is, and most of them stay out there most of the time. But every so often, one will come in and pass near the sun. And when it passes near the sun, this ice evaporates, and that's what makes the tail. So where are these comets? This is another figure from chapter 12 of your book, and you should definitely study this one. Most comets are out here beyond Neptune's orbit and even beyond Pluto's orbit. There's a region called the Kuiper Belt, which is from about 30 AU, which is about where Pluto is, to 50 AU from the sun. And it turns out that these comets mostly have very, very consistent orbits. They orbit just the way planets do. They're very predictable. They orbit in exactly the same way as planets. Halley's Comet is a Kuiper Belt comet. If we think about Pluto as if it were a comet, Pluto would be a Kuiper Belt comet. The other dwarf planets are part of the Kuiper Belt. And there's about 100,000 of them that are more than 100 kilometers across. But if you go even further out, even as far as 50,000 AU, which is getting close to a light year away from the sun, there are like 1 trillion comets. And they're all just flying around completely randomly. These guys are in a single plane, more or less, just like the rest of the solar system. But these guys are in a huge sphere all around the solar system. And they have very random orbits. They are very, very, very unpredictable. And so if one of these comes in towards the sun, we usually don't know that it's going to happen until it starts happening. So in the case of most of the objects that we're studying, we can kind of predict when they're going to come, and we know when that's going to happen. So if there were one that was going to hit Earth, we could come up with ways to defend against it. It's much harder to defend against something that you don't know that it's coming. This region that's further out is called the Oort cloud. Kuiper and Oort are names of astronomers that found these things. So Kuiper Belt and the Oort cloud. Finally, we have meteors. Occasionally, excuse me, I had to pause for a second there. Occasionally, we do get little pieces of this debris in space that come into the Earth's atmosphere. When I say occasionally, actually, this happens on a daily basis with little bitty ones. I'm not talking about the big guys, but little bitty chunks of asteroids and comets hit the Earth's atmosphere on a daily basis. So whenever one of these things does hit the Earth's atmosphere, we then call it a meteor. Any asteroid or comet that enters our atmosphere, we rename and call a meteor. Doesn't matter how big it is or how small it is. If it's a grain of dust from space that hits the Earth's atmosphere, that's a meteor. Sorry again, I'm getting lots of visitors this morning. So anyway, most meteors do not actually hit the ground. The vast majority of them burn up in the atmosphere. I'll talk more about that in the next lecture, but most meteors burn up in the atmosphere. However, occasionally one hits the ground and then it gets renamed again as a meteorite. So there's a difference between a meteor and a meteorite, and the difference is that a meteorite hits the ground. So if anybody asks you, where would you look to find meteors? Well, first off, you would look for meteorites that are on the ground. And as you can see in these pictures, the people are looking for them on ice. In fact, that is Antarctica. And the reason you look at Antarctica is just they're easy to find in Antarctica because the ground is white and the meteorites are black because they have been burning in the atmosphere. They have this sort of charred outer layer. It's like melted rock that has solidified again. If you've ever seen volcanic rock, when you take molten rock and then solidify it, it becomes black. So black rocks sitting out on the middle of white ice are easy to find. You also find these very easily in deserts, but they can be found any place on Earth. They are, in fact, everywhere. It's just that some places are easier to find them than others because of the conditions of the ground. Also, in Antarctica and in the deserts, we don't have a lot of erosion. There's not a lot of rain, there's not too much wind, and so it doesn't erode the meteors away. Whereas in other locations, you might start eroding the meteors, you might start getting them contaminated with earth materials, and then it's harder to find them and confirm that they're meteorites. So the most common places to look for meteorites are places like Antarctica and various deserts. In the next lecture, we'll talk more about what do the effects of meteorites, how do they burn up in the atmosphere, and what happens if they actually hit the ground.